3.1, given that k is equal to the sum to infinity of the given series beginning where n is equal to 1, right? So now 3.1.1 determine the values of x for which k converges. So since it's the sum to infinity, first we know that we are going to get the terms as into x minus 1 to the power of 1 plus into x minus 1 to the power of 2 plus into x minus 1 to the power of 3 plus up to infinity, right? So if we are looking for the common ratio, we are going to say term number 2, which is into x minus 1 to the power of 2 divided by x minus 1, and then we get x minus 1. So we know that the series will converge where the common ratio is between -1 and +1. So now we just substitute r with x minus 1. We get -1 is less than x minus 1 less than 1. So we say -1 plus 1, we get 0 less than, and then is x minus 1 plus 1, we get x, and then now is 1 plus 1, which is 2. So this series or k will converge when x is equal to 0, or not equal to 0, but between 0 and 2. It will converge if x is between 0 and 2. Sorry for that. So now let's continue. So 3.1.2, calculate the value of k when x is equal to 2 divided by 3. So if x is equal to 2 divided by 3, we know that r will be what? 2 divided by 3 minus 1. And then this is the same as 3 times -1 is -3. So it's 2 minus 3. We get -1 divided by 3. And then it means the first term will be -1 divided by 3 as well. So we calculate the value of k, which is the sum to infinity. The sum to infinity is equal to the first term divided by 1 minus the common ratio, where r is between -1 and 1, right? So we have -1 divided by 3 divided by 1 minus into -1 divided by 3. So this is the same as what? We keep the numerator is -1 divided by 3. We change the division sign, and then we flip the denominator. So the denominator is the same as 4 divided by 3. So we flip it, it becomes 3 divided by 4. So this is the same as what? As -1 divided by 4. This means the value of k is -1 divided by 4. Now let's continue. Question 4. Consider the function f of x is equal to -2 divided by x minus 1 minus 1. 4.1, write down the equations of the asymptotes of f. So function f is a hyperbola function because x is part of the denominator, right? So the minute x is our denominator, it means we are dealing with a hyperbola function. So with the equations of the asymptotes, we have the vertical asymptote, right? So with the vertical asymptote, we concentrate on the denominator, and then we say x minus 1 is equal to 0. This is the dotted line that cuts the x-axis but is parallel to the y-axis. So it means x is equal to 1, right? We get a mark for doing that. And then with the horizontal asymptote, this one is y equal to the constant, which is -1. Is the dotted line that cuts the y-axis but is parallel to the x-axis, right? And then that's 2 marks for that. So 4.2, calculate the intercepts with the axis, right? So we are going to calculate the y-intercept and the x-intercept. Now let's start with the y-intercept, the y-cut. We know that x is equal to 0. That's where your graph will cut the x-axis. At that point, x is equal to 0. So we say y is equal to -2 divided by 0 minus 1 minus 1. So this is the same as what? We know that -2 divided by -1 is +2 minus 1, we get 1. It means the y-intercept is at where y is equal to 1 and x is equal to 0 there. So with the x cut, we know that y is equal to 0. That's where your graph of f will cut the x-axis. At that point, y is equal to 0. So we say 0 is equal to -2 divided by x minus 1 minus 1. So we transpose. You move -1 from the right hand side to the left hand side, we get 1. We cross multiply it into x minus 1. This is equal to -2. So is x minus 1 equal to -2? So x will be -1. It means your graph of f will cut the x-axis at x equal to -1, right? And then we get 3 marks for doing that. Now 4.3, on the diagram sheet provided, draw a graph of f showing all asymptotes and intercepts with the axis, and then that's 3 marks, right? So let's draw the graph of f. So we have the Cartesian plane, we have the x-axis and the y-axis, the asymptotes. We have x is equal to 1, y is equal to -1, x, y cards, we have x is equal to -1, y is equal to 1. So now let's draw the asymptotes. So we have the line y is equal to -1, we use the dotted lines, and then we have line x is equal to 1, and then at this point that's where they intersect. And then now, since the value of a, remember we have y is equal to a divided by x plus p plus q. So the minute the value of a is less than 0, it means it's negative, right? It means we are going to draw our graphs in the second quadrant and the fourth quadrant. So it means now we plot the x and y curves, which are the intercepts. So x is -1, and again y is +1. So it means we're gonna have the first graph in this quadrant, and then you have to know that the graphs will never cut through the asymptotes. They will get closer and closer and closer, right? So make sure that everything that you do is accurate. Never let this graph cut the asymptote. So again, another one is in this quadrant, and then it will move like this, and then it will get closer and closer to the asymptote, but it will never cut the asymptote. And then at this point we have -1, which pairs with 0, and then here is 0, which pairs with 1. And then at this point we have what? 1, which pairs with -1. Is the point of intersection of the two asymptotes. And then now by doing this we get 3 marks, right? Let's move on. So now with 4.1, determine the equation of the axis of symmetry of f with a negative gradient. So we have the equation of the axis of symmetry with a negative gradient and positive gradient. So since we are discussing a hyperbola function, we are going to determine the 2 equations, right? So but first let's just determine what is required of us. So it means we are going to concentrate on this part of our function, right? So we have f of x is equal to plus or minus into, and then we write the denominator, and then we say -1 there. So with the negative gradient, it means y is equal to negative into x minus 1 minus 1. So y is equal to negative times x is negative x, negative times negative times -1, sorry for that, is +1 minus 1. So y is equal to negative x, right? This is what we are looking for. and then we answered question 4.4. So if you're looking for the equation of axis of symmetry with a positive gradient, it means you're going to say y is equal to, we use positive, we say x minus 1, and then we get xs, we get y as x minus 2. It means y equals to x minus 2 is the equation of axis of symmetry of f with a positive gradient. With negative gradient, we get x is equal to negative x. We get y is equal to negative x, sorry. And then that's 10 marks. So now, next time they will look for the axis of symmetry with a positive gradient, you will know that you have to do this. So now, let's move forward to another graphs and functions questions. Question 7, the point A lies on the graph of f of x is equal to 3 to the power of x plus p minus 27. The minute the independent variable, which is x, is your exponent, it means we are dealing with an exponential function. So we are given a point on f, and then we are given the coordinates of these points as follows: 3 pairs with 54. So 7.1 determine the value of p. So we know that we have x and y, right? So we just substitute, we say 54, this is equal to 3 to the power of 3 plus p minus 27. So we transpose is 54 plus 27, this is equal to 3 to the power of 3 plus p. So it becomes 81 is equal to 3 to the power of 3 plus p, and then 81 is the same as 3 to the power of 4. This is equal to 3 to the power of 3 plus p. So we have the same base on either side of the equal sign. We ignore the bases and then we equate the exponents. So it means p is equal to 4 minus 3, we get 1. So the value of p is 1. 7.2, determine the range of f. So with the range, you don't have to draw the graph, right? You just have to work out the value of the y-intercept, right? So we say 3 to the power of what? We know that if we are looking for the y-intercept, we put x equal to 0, so it's 0 plus 1 minus 27. So it's the same as 3 to the power of 0, which is 1 times 3 to the power of what? So 1 times 3 is 3, minus 27, we get minus 24. So minus 27 is our asymptote. So this means the graph will be above the asymptote. Therefore, y is greater than negative 27. This is the range, right? You can say the range is what? Y is the element of real values given that y is greater than negative 27, and then this is the range. 7.3, so graph G is obtained by reflecting graph F about the x-axis. The minute they reflect a graph about the x-axis, it means it's about the line y is equal to 0. Line x equals to 0 is the y-axis. Line y equals to 0 is the x-axis, right? So determine the coordinates of the y-intercept of G. So when you reflect a graph about the x-axis, it means you multiply y by negative, and then we get 3 to the power of x plus 1 minus 27. And then now let's divide. We say y is equal to, we are going to say 3 to the power of x plus 1 divided by negative 1, we get negative 3 to the power of x plus 1, and then negative 27 divided by negative 1, we get plus 27, and then this is the graph of G. G of x is equal to negative 3 to the power of x plus 1 plus 27. So if we are looking for the y-intercept, we know that x is equal to 0. You just say y y is equal to negative 3 to the power of 0 plus 1 plus 27. And then what do you get? What do you get? So you just use a calculator there, you'll get the max. So you get positive 24 as the y-intercept of G. And then we get 2 marks. First, we reflect it about the x-axis, and then secondly, we work out the y-intercept. Question 5. Given that f of x is equal to negative 2 divided by x plus p plus q, the equations of the axis of symmetry of f are y equals to negative x plus 8 plus y is and y is equal to x plus 2. Sorry for that. So determine the values of p and q. So the values of p and q, we know that these two equations, they intersect, right? So it means we are going to say negative x plus 8 is equal to x plus 2, and then we work out the value of x. And then now we are going to say negative 2x, because negative x minus x is negative 2x. This is equal to 2 minus 8, we get minus 6, right? So you just move x from the right hand side to the left hand side, and then it becomes negative. And then you take you move 8 from the left hand side to the right hand side, it becomes 2 minus 8. So we divide, we get 3. So for us to get the value of p, we are going to say 3 plus p is equal to 0, and then p becomes negative 3. We get p as negative 3. So what about q? So you just say y is equal to negative into 3 plus 8. What do you get? You get positive 5. It means q is equal to 5. That's how you get these values of p and q. So if p is equal to negative 3 and q is 5, indeed, right? Determine the coordinates of the x and y intercepts of f, right? So let's work out the x and y intercepts of f. So with the x card, we know that y is equal to 0, and then we say 0 is equal to negative 2 divided by x minus 3 plus 5. So we move positive 5 from the right hand side to the left hand side, we get negative 5, and then we cross multiply, we have negative 5 into x minus 3. This is equal to negative 2. Is negative 5x plus 15 is equal to negative 2. So it's negative 5x, and then you move positive 15 from the left hand side to the right hand side, we get negative 2 minus 15, which is negative 17. So it means x is equal to 17 divided by 5. That's the x-intercept. So with the y-intercept, which is the y-card, we know that x is equal to 0 at that point, and then y is equal to negative 2 divided by 0 minus 3 plus 5. What is the value there? We have 2 divided by 3. So 3 times 5 is 15, right? So it means 2 plus 15, we get 17 divided by 3, right? That's the x-intercept, and this one is the y-intercept. And then we get 4.